Web 3.0 is an unstoppable force that continues to completely change the game for multiple industries. And one major industry that's a victim of this disruption is gaming. We've seen a ton of crypto games explode onto the scene in the past year. It's one of the fastest growing ecosystems in crypto. And today you're going to learn how to create a blockchain-based game with NFTs step by step. This is an amazing project to learn the fundamentals of blockchain development, how NFTs work, and a project that you can use for your portfolio if you're trying to land a high-paying Web 3.0 job. You don't have to be an expert to get started today. You'll learn all the programming languages, skills, and technologies as you go. How to write the smart contracts with Solidity, how to build the game, and how to put your project out there live on the blockchain. So I'm super excited for you to learn this today. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to master blockchain step by step from start to finish, then head on over to dappuniversity.com/bootcamp to get started today. So if you have been watching this channel for a while, then I want to introduce you to somebody who's helped me put together this tutorial today. I've invited on Victor, who's a total expert in this topic, who's created this game, and he's going to walk you through this entire process step by step. All right, Victor, so what are we talking about today?
Today we'll create an entire blockchain game. This game will be a runner game where you can collect NFTs and redeem them on the blockchain. So you will own real NFTs by playing this game on the blockchain.
Yeah, very cool. This is super exciting because blockchain gaming is really exploding. This is a super hot trend. Lots of people have been asking me, hey, how do I build a blockchain game? So let's jump in and get started.
Let me give you a quick overview of the game that we're going to build. So to start playing this game, you just have to press any key. And then this person is running where you should avoid these obstacles. And while running, you can collect these NFTs. We'll build this game using HTML, CSS, and JavaScript. And this is where it shows your total score. And later, after you finish playing the game, you can connect your MetaMask and claim your tokens and your NFTs on the blockchain. Before we start developing the game, it's very important for us to understand some key concepts that we're going to use through developing this game, like what is the blockchain, what are NFTs, tokens, and how are blockchain games different from regular games. Let's start with the first one. What is the blockchain? The blockchain is a decentralized network of computers all over the world. And these computers are called nodes. And you can even create your own node and help to secure the network. So the blockchain is decentralized and there is a copy of the blockchain data stored on the blockchain on all of these nodes, which means that you cannot delete the data because the blockchain is immutable. And we'll develop our game as a website, but we'll store all the rewards such as tokens and NFTs on this decentralized network. What are tokens? Tokens are digital assets on the blockchain that you can create and transact between addresses. And this is different from cryptocurrencies. Cryptocurrencies are basically the native token on the blockchain that was created when the blockchain was created itself. So for example, on the Ethereum blockchain, the native token is Ether. And we'll create our own token for our game and we'll deploy it on the blockchain. And this is what we'll use to reward the player. And what are NFTs? NFTs are similar to tokens because they're also digital assets on the blockchain. But instead of digital money like tokens are, NFTs are unique. And how are blockchain games different from regular games? Blockchain games are different from regular games because in blockchain game, the in-game items you get are stored on the blockchain. And in the regular games, the in-game items are stored on a central server instead of a decentralized network like the blockchain is. And because it's stored on a central server, it means that the company who created the game, like Fortnite, can block your access to your in-game access and delete your account. But in blockchain games, you own the in-game's item because they are stored on the blockchain. And the blockchain is censorship resistant, which means no one can block access to your items. And also because the items are stored on the blockchain, this means that you can easily use one item in one game into other blockchain game. Like using the skin you had in Fortnite in Minecraft. Let's get a high-level overview of how our game will work. We have our users that want to play the game. We'll create a website for the users to interact with using HTML, CSS, and JavaScript. And this website is where you can play the game. But after you finish playing the game, you have collected NFTs and you have some score and you want to get the rewards. We'll use the smart contract that will deploy on the blockchain for that. We'll create a run token contract. This is the token that will reward our users based on their running score, and we'll deploy an NFT collection that we're going to reward our users. And these smart contracts are going to be deployed on the Polygon Mumbai testnet. And this testnet is very similar to a real blockchain, but it uses fake Ethereum and is created for development purposes. For this project, the technologies we're going to use and dependencies are, first of all, Solidity for writing our smart contracts. Solidity is a programming language that we're going to use to create our smart contract on the blockchain, our NFT, and our token smart contract. And this is a programming language specifically designed to implement smart contract. And then we're going to develop our game in the browser using HTML. This is a language to develop the structure of our website, CSS to style our website, and we're going to use JavaScript for the website interaction. We're going to deploy our smart contract on a public testnet. And a public testnet is the closest thing we have to real blockchain, but this testnet is created only for testing purposes. And to connect to these testnets, you have to have a node, because the blockchain or the testnet is just a network of computers. And instead of running our own node, we're going to use Infura as a node provider. So Infura will create a node for us. Then you have to have Node.js installed and npm to install all the dependencies we're going to use. And we'll use Hardhat as our Ethereum development environment. Hardhat basically has all the tools you need to develop, debug, test, and deploy smart contract. And we'll use Ethers.js to interact with the blockchain. So after creating the website and deploying the smart contract on the blockchain, we need a way for the website to talk to the smart contract and reward the player NFTs. And for this interaction, we're going to use Ethers.js. This is a JavaScript library that allows our frontend to talk to the blockchain and our smart contracts. So to start creating our app, just open an empty folder inside Visual Studio Code. And then we want to create a new file by right-clicking New File. And this is going to be our index.html file. This is going to create the structure of our app. Inside here, we want to say exclamation mark, then press enter, and this should give you a boilerplate code for our website. Inside here in the title, we want to replace this document with something like blockchain game. So this is the structure of our app, but all the styles are going to be stored inside a new file that we'll create and call styles.css. And inside our HTML, we want to link to this file by using the link tag. And inside this href attribute, we want to say styles.css. And whenever the user interacts with our app, we want to create a JavaScript file for this, and I'll call this script.js. And I also want to link this once again, but this time using the script tag. And in this attribute, you want to just provide the path to your file. In my case, script.js. Inside the body, I will create a button. We'll have 3 buttons that will interact with the blockchain. And we have a claim NFT button here with a class of button1. And this class just gives style and position to our button that we'll create later using CSS in our styles.css. We have an onClick function called claim NFT, and this will be called, and we'll create this inside a separate JavaScript file. And this function will interact with the blockchain and claim our NFT. And similar to this, I'll create another button called this claim tokens. This will claim the tokens. It will have the class of button2. And also, before we claim our tokens and interact with the blockchain, we have to connect our MetaMask to our website using this connect MetaMask button with a class of button3. And when you click this, we'll handle this inside the JavaScript file, and this connect MetaMask function will be called. In this game, we'll have a total score and we'll have a current score. And for this, I want to create an NFT total score span, starting from zeros, of course. And this is the total NFTs you have collected throughout the game that you can claim later using this claim NFT button. And inside this script tag, I want to add token equal module, because we're going to use this script as a module. And this type equal module allows us to add these data attributes that we'll use to reference this span later using JavaScript. I'll create a new button and call this way total score. And I'm saying GUI because the score is going to be given out in GUI. And GUI is the smallest unit of measurement of Ether that you can use later to swap with real tokens. These will have these data attributes that we'll use to reference them later in JavaScript to update the score, and classes to create the position and their style. We'll have an NFT score button, a GUI score button. This is the current GUI and NFT score you have. And we'll put everything inside this div tag with a class of name and this data game attribute. We have another div which says press any key to start. And to add our graphics in the game, I'm going to add this assets folder. Inside this assets folder, I have all the images I'm going to use for my game. I have the ground here. This is what the runner will run on. Then we have an NFT image. This is the NFT you will collect. Then we have obstacles that you have to jump over. We have a player jumps image, and this will be shown whenever you jump. We have a player runs 0 and player run 1, and we want to change between those two images to make it seem like the player is running. And when you start the game, the player will just show this player stands image. And once we have our assets in our project, I'll create this image tag now. And this image tag will hold the ground image. It will have a class of ground and this data ground attribute that we'll use to reference this image later. I'll also create another identical image tag because we'll show this ground image once. And once this basically goes out of our view, we want to show another image, and we'll just keep looping through these two images. Then we want to reference our ethers.js library. This is what we'll use to interact with the blockchain, and we can do this using this script tag. And lastly, I want to create a new blockchain.js file that we'll use for our blockchain logic, and we'll just reference this file here. Let's now go ahead and implement this script.js file, and here I'll create the game width. This is how long our game will be, our running track. We want to create a constant for our game height. This will be 30, so not very tall. And we want to make this game to be harder, and I'll create for this a speed scale increase variable. And of course you can adjust this, but let's not make this game very hard and just put this value very low. And I'll now require all the elements I need. For example, the game element. This is the main element that will put everything in, and we need those in JavaScript. I'll require the score element, the start screen element, this GUI total score element, and the NFT total score element, and also the NFT score element. We want to make our game responsive, and for this I'm going to create this set pixel to game scale function, and this function will basically just scale our game based on our screen size. And I'm going to create a game to pixel scale variable and just check if the window.inner width divided by the window.inner height is less than the game width divided by the game height. And if this is true, we want to assign window.inner width divided by the game width to this game to pixel scale. Or in the other case, limit this based on the height. And we'll just update the width and height in our game element in these two lines. And I'll call this function right above here. And I'll just add an event listener. So whenever you resize, we'll call this setPixel to game scale function. And then as in every game, we want to have some sort of a game loop. And this will be our update function. And we'll call request animation frame on the window object. And this function basically is getting called whenever we can render content on the screen. We'll pass the update function in here. And also once again call the same exact thing inside the update function so we can create a loop. Inside the update function, we want to update our player on each frame, and we calculate this using the last time variable. For the first time, it will be null, and we want to set this last time variable to the time it took, and then call this update function again and just exit out of the function. We'll calculate the time between frames with this delta variable because we want to only update our ground, player, obstacle, and other things on each frame. And we haven't created these functions yet, but we'll create this function in their files. For example, we'll have a ground file that will create the update ground function, and the same for player and obstacle. And each time this update function gets called, we want to check if you have lost. We haven't implemented this function yet. And if this is the case, we'll just handle lose, just reset all the variables and stuff like that. Here I will just say document.add event listener, and this will handle the starting of the game. So whenever you press some key, we'll call this handle start function only once. And I'll delete this here because this needs to be in the function. And above here, I will import the update ground and setup ground function from the ground.js file. We haven't created this, but basically we'll call the update ground. Actually, we're calling it right now. We'll call the update ground function in our update function, and we'll use the setup ground to set up our ground image. And in here, I also want to import the update player, setup player function we'll create this player.js file later. We'll create an obstacle file for our obstacle, and we'll create an NFT.js file very similar to the obstacle file we have here. In the player file, we'll have a setup player function that will set up the player only once. We have a getPlayerRect function. This will get the dimensions of our player so we can use them later to see if we have any collisions with this obstacle. And similarly, we have an update obstacle function, a setup obstacle function. We have a function again that takes in the dimensions of this obstacle. We have an update NFT, setup NFT, and again a get NFT rect function for the NFT image. So let's now implement all the functions that we're calling in this update loop, like the update speed scale and the update score. First, I'll create a function called checkLose. This will check if there is collision between the player. This uses an isCollision function that we'll create here. This one takes in rect1 and rect2 and just checks if there's a collision. In a similar way, I want to create the check if we got an NFT function, but inside here I want to get the player rect and again use this isCollision function. And inside here, if this is true, if there is a collision, we want to remove the NFT and we want to update the current score by 1. And of course, update the UI. We'll create an update speed scale function that takes in the delta. This will update the speed scale by just adding the delta times the speed scale increase variable. Then we have an update score function that again takes in the delta and just adds the delta times 0.01. This is our current way score that we get, and we want to take in the score. Just make sure that this is a whole number by using this math.for function and update the UI or our score element. Then we have our handle start function, and this is where we'll call all the setup functions for our ground, player, obstacle, and NFT. And of course, we'll reset the score and other variables. We want to, of course, hide this start screen that says press any key to start, and we'll call the request animation frame. And for the handle lose function, I'll create a total NFT score and a total GUI score on my window object. And this is an object that you get in the browser. And I'm purposely creating variables on this window object because I want to later have access to them in my blockchain.js file, because I need this, I need the total NFTs I have to interact with the blockchain and claim my NFTs. I'll call this handle lose function, and in here I just want to add the current score I have. So this is happening after I lose my game. I'll add the score I got from this current session, and I'll add my NFT score. Then I'll take in my NFT total score element. This is the UI, and this element, and just update the score. And just reset the NFT score to 0. Also, after 100 milliseconds, we want to listen again for events. So when you click the button, we're ready to start the game. And before we create our ground.js file, we will create an update custom property.js file by right-clicking new file, then saying update custom property.js. And we need this file because we're going to do a lot of times in JavaScript. We want to take in a CSS variable of our element and we want to update it using JavaScript. And this is what the get custom property is. So we're getting the prop, we're getting a property of this element, and we're just returning it so we can use it in JavaScript. And also we can set this a custom property and we can increment this custom property. Let's create our ground.js file. So I'll say ground.js. Inside here, I want to just get a hold of the get custom property and all the other methods that we developed in this file. And also I want to I'll define the speed as 0.05. This is the speed at which the ground will move. I'll get my ground using this data ground attribute. And this is how we're using the function in our update custom property file. So when we set up the ground, the left property will be 0 of the first element, because remember in the HTML we put in 2 grounds, and on the second element it will be 300 because this is the width of our game. And we'll create the update ground function that we called in our script.js. And inside here, I want to loop through the 2 grounds that I have. And I want to increment the custom property so it moves. And I want to times this times -1 because it's moving backwards. And once the first ground gets out of screen, we want to update the second one. And basically just if it's -300, the left property, we want to add 600. Let's create our player.js file now, and inside here I'll just import these functions that we created in our update custom property file. I'll take in the element, our player, the jump speed will be this much, and the gravity is this much. You can of course tweak this as you like. Then I'll create this player frame count variable, and this basically says that we have 2 images and we want to change between them, so we make it look like the player is running. The frame time is 100, and I'll define this is jumping and other variables to set up my player. I'll use the set custom property to set the bottom property of my player to 0. And also I want to add an event listener, which is key down, and this will call our onJob function that we haven't created yet. And also I want to create an update player function. We are already calling this in the script.js file. This takes in a data and a speed scale. We want to handle the run here and handle the jump. We'll create this function now. We'll create a getPlayerRect function. This one takes in the dimensions of our player element. This is the handle function that we are calling whenever we update the player. Inside here we want to check if the player is jumping, and if it is, we want to assign to him the player jumps variable. This is our logic where we change between the two images that we have to make it seem like the player is running, and we'll just add this to the current frame time. In here I'll create the handle jump function, and if the person is not jumping, we want to exit out of this function. And of course, whenever this player jumps, we want to increment their bottom property. If this bottom property is less than 0, we'll just say that jumping is equal to false. And lastly, I'll create the onJump function. So this one just checks if we have hit space or is it jumping. And if that's the case, we want to exit out of this function because we don't want to jump again. If we are jumping, we just update these properties. Let's now create our obstacle.js file. In here, I will just import all the function from our update custom property file, and I'll create these three variables: the speed of our obstacle, the obstacle minimum interval, this is the minimum time to spawn each obstacle, and this is the maximum time. We'll get the game element using the data-game property. We'll create a setup obstacle function and create this next obstacle time variable. We'll initialize this to the minimum interval time, and when we set up an obstacle, we want to remove all the remaining obstacle with these lines of code. Then create the update obstacle function that we're calling in our update game loop. In this function, I'll just query all the obstacles that we have, and if these have a left property less than -100, and this is defined in the CSS, we'll remove them because they're out of screen, the player doesn't see them, and there's no point in them being around. And then we'll check if this next obstacle time is less than 0, and if it is, we want to create a new obstacle. How do we calculate the next obstacle time? We basically use this random number between function. We'll have a getObstacleRect function. This one gets the dimensions of our obstacle. Create obstacle function. In here, we are just creating a element on the document. This is just an image tag. And in this line, we are creating the data obstacle property so we can reference it later. We're setting an image, of course, so we can see the obstacle, and we're just adding this to our game. And in a very similar way, I'll just click new file here, create an JavaScript. So in a very similar way, I will create my NFT. Everything is pretty much the same from the obstacle, but of course in here we want to set the NFT image when we are creating the NFT. We have again a random number function. We have a getNFT function, rects, that gets the dimension, update NFT, and setup NFT function. I even have the same minimum and maximum interval. Of course, you can change this as you like. And also in the obstacle.js file, I will add this random number between function. And also I will rename my assets folder into images because that's how I'm referencing this folder here. And now we are ready to try out our game. To run my index.html, I need a server, and we can install this using the live server extension inside the extensions tab. And once you have that installed, go back into files, and on the index.html, we can right click and choose open with live server. And this will open our game inside the browser. So as you can see, we have a press any key to start. This is our start screen element that we've defined in our HTML. We have our three buttons that should connect us with the blockchain inside the blockchain.js file, but we haven't implemented that yet. And we have all these buttons here that are styled and positioned using all the CSS I've added here. So we have all the classes that we have added in the index.html to our elements. And we can start the game by pressing any key. So as you can see, we're changing the images. We're changing in between those two images that we have. When we're jumping, we are setting this jump image. We have our ground here and our obstacles. And this is our NFT images that we can collect. And whenever there is a collision to the NFT, we are just removing the NFT and adding it to our score here, our current score. And we have a total score here that we can use later to claim our NFT. And this game is not finished yet because we have to create the blockchain part of our game. We have just score now and we can't claim any NFTs or tokens. So let's go ahead and create the smart contract for this game. And now to create our smart contract for this app, open a new folder inside Visual Studio Code. I'll name mine Hardhat, and open new terminal by going inside terminal. And we'll use Hardhat to create and deploy our smart contracts. And Hardhat, as I said before, it has all the tools you need to develop and deploy smart contracts. And to create a Hardhat project, you have to say npx Hardhat. This will prompt you to choose between 4 different types of Hardhat projects. We'll go with the basic sample project. This is the root, so press enter. Then yes, we want to add a git ignore, and yes, we want to install these dependencies. Now our Hardhat project is creating, and here in our Hardhat project we have a contracts folder. This is where we'll write our smart contracts. This is where we'll write our smart contracts, our token and NFT smart contract. And we already have a greeter example smart contract. We have our node modules. These are all the packages that we use in our project. We have a scripts folder, and this is where we'll write, and we already have a JavaScript script that deploys a contract. And you can write JavaScript scripts for many different things than deploying the contract. Then we have a test folder. In here we can write tests against our smart contract, because once we deploy the smart contract to the blockchain, it's immutable, which means you cannot change it. So it's very important to test our smart contracts. We have a git ignore file, and this is also very important. This is a Hardhat configuration file. This is where we will configure our public testnet that we're going to deploy our smart contracts to. Then we have a package.json file that specifies all the dependencies that this project uses, and a simple readme file. Let's now try to develop our smart contracts for my token. Into the contracts folder, I want to right click new file, call this run token.so, and .so stands for solidity. I'll write this comment here so the compiler doesn't present any warnings. And we want to provide the solidity version we're going to use with the pragma solidity statement. And let's use the 0.8.0 version or any version above. We can create a contract by using the contract keyword and then just say run token. And to create our token, we'll use the ERC20 standard. And this is a standard that all the tokens use because we want to have some sort of a standard. So when you deploy token on exchange, it can be easily exchanged and swapped with other tokens. And we'll use an implementation of this ERC20 from the OpenZeppelin library. And we can import this standard by saying import OpenZeppelin and ERC20 contract. But to install this library, we have to say npm install and then OpenZeppelin contracts. Now once we have installed the library, we can inherit from this contract by just saying is erc20, and we have to override the constructor for this contract. I'll first create my own constructor from this contract, and in here basically this constructor is a function that gets called only once when you deploy the contract. And here I want to call the ERC20 constructor that expects 2 arguments. The first one being the name of our token, which we'll call just run token. And the second one is the symbol, which will be run. And in here I can just mint 20 tokens to the sender. And I can do this by calling the mint function of the ERC20. And this one expects the address that will send the tokens to, and the address will be message.sender. This is the person that will deploy the contract, and we'll give them 20 tokens. And also here we need to provide the decimals, and we can do this by multiplying by 10 to the power of 6. And this 10 to the power of 6 means that our token will have 6 decimals. Then let's create the function that will call, or the player will call, from our website that we have created previously. And for this, I'll create a function, call this mint tokens. This one will take in an address. This is the account. This is basically the player who played the game. And it will also take in a amount. This is their actual score. And then, as we did above, we'll just call the mint function with the account and the amount. And also this is a public function. So what this mint tokens function will do, it will just give this amount of token to this account. Let's now go ahead and create our NFT collection. So we'll create a collection where player will just mint an NFT by just going into the contracts, new file, and I'll call this just runner collection. We'll provide the same Solidity version here, create a contract, call this again runner collection. And inside here, I'll once again use the library. In here, once again, I'll use the OpenZeppelin library and import an NFT standard, specifically the ERC1155. There's a lot of NFT standards, but the most commonly used are the ERC721 and the ERC1155. And this ERC1155 is sort of like a combination between the ERC721 and the ERC20, because the ERC721 it allows you to deploy a unique NFT, but with the ERC1155 you can have multiple NFTs. Let's inherit from this contract by saying is ERC1155, and for any NFT collection you would have to have a name. This will be a string, public name. You would have to have a symbol. This is also going to be a string. String just means text. We'll have the token count. This is the count of how much NFTs we have. This will be a number. And we'll have a base URI, which is string. And this base URI is basically just a link that points to our NFT collection who is uploaded on IPFS. We will not store the actual NFTs here. We'll just point to them using this base URI. And again, we have to create a constructor. And this time we'll have some arguments in the constructor, like the name, the symbol, and the base URL. And we'll just again call this ERC1155 constructor. We'll pass in the URI here, and we'll just set our variables. Inside here, I'll create a mint function that takes in an amount, and this amount is basically the NFTs score that you had in the game. So we'll call this mint function from the front end. Basically, the player will call this function with their NFT score, and we'll just increase the token count because we're minting an NFT, and we'll mint this to the sender, pass the token count in our mint function, and the amount. And also we have an extra argument here. This is just extra data, but we're going to leave this empty. And for our NFT to work with OpenSea, we have to override this URI function that takes in the token ID of the NFT. This is a public. We are overriding this function, so we need to pass this override keyword. This is a view function because it will only return a string. And this URI function just takes in, basically what it does, it takes in this token ID of the NFT and it returns the URI or the link where this NFT is uploaded on IPFS. So let's return a string in here. We'll say abi.encode_packed and we'll just pass the variables that we want to combine here. We want to combine the base URI. This is where our entire collection is stored. We'll deploy this later on IPFS. Then we have the token ID. We have to convert this to string because it's a number here. And for this, we'll use a strings contract that we'll import here again from OpenZeppelin because Solidity doesn't work very well with strings. And also we want to add .json because all our NFTs are going to be just JSON files. Let me now show you how you can create the data for your NFT. And an NFT is just a JSON file, as you saw here. So I'll import my NFT metadata here. And in here what I have is I have an images folder, and these are all my images for my NFTs. I have a gold image here, monkey, a rock, champion, and a dog image. And in my other file I have my actual NFTs labeled 1 through 5. And in here, in each of these, I'm just providing a name, description, and I'm providing a link to an image. This is very, very important. A link to the hosted image on IPFS. You'll see how you can deploy this on or upload this to IPFS later. And some attributes, so each NFT can have any attributes. So my first JSON file points to my first image, which is of course the goat image. My second file, which is a monkey, points to the first image. You can see 11.png image, and if we see this 11.png, you can see it's a monkey, and that's very similar to the other NFTs. And to upload our NFTs to IPFS, we will use a service called Pinata, and this Pinata basically connects us. It allows us to deploy NFTs on IPFS, and IPFS is a way to store data in a decentralized way. So to upload your data here, we'll just click on upload and we'll say folder. And first we have to upload the images. So click on select, choose your folder, and then you need to give it a name. I've already deployed my images here. And when you deploy content on IPFS, you will be given this CID, which means content identifier. And this is what we'll use to identify this data on IPFS. This is what we are using for the images in our JSON file to point to these images. So you can see that this CID of my images is the same as this CID that I have here. This points to the folder of images that I have deployed. And to get to the first image, you just have to say slash and then the name of this file. To make sure that your image is correctly stored on IPFS, you can command click this link, and if this link opens up your image, that means that everything is fine. And once we upload these images, we want to, like I have done here, just point to each of the images in their respective NFTs. So in my first JSON file or NFT, I'm pointing to my first image, and I'm doing the same thing in the other JSON files. And now our JSON files are ready to deploy. So once again, go to Pinata, click on upload your folder, and you will get a CID as we got with our images. Once we have the data, let's create the scripts that will deploy our NFT and token smart contract on the testnet. So go into scripts, click on new file. I'll just call this deploy run token.js because this will be a JSON file. And we already have a deploy script in here, and our script will not be much different. So just copy this one, go into deploy run token script, paste this in, and what this script does, it just calls this main function over here. And inside this script, what we're doing is we're using the ethers object, so the ethers.js library, to get a contract factory of this greeter contract. But now we want to actually, instead of greeter, use our run token contract. We are storing this inside this greeter variable. Then we are deploying the contract, and this one takes in an argument, but in our run token we do not take any argument, so I'll just delete this. And once this is done, we await this call, and we get the contract in as a JavaScript object. We finally wait for this to be deployed, and once it's deployed, we are just printing out the contract address. Let's create the deploy script for our NFT collection now by just saying new file, then say deploy NFT collection. I'll paste in the same code that we had in our sample script, but once again, instead of deploying the greeter contract, I want to deploy my runner collection. And this contract, as you see here, takes in 3 arguments that we need to pass when we deploy the contract instead of 1. So delete this one. And in here I want to pass in the name of our collection, which will be runner, the symbol, which will be run, and the base URI. This is the URI where our NFT collection is stored on IPFS. And this one will be stored at ipfs.io/ipfs and the content identifier. And you can get this from Pinata. This is just my CID, yours will be different. And the last thing for the deployment of our contract is we need to configure the Mumbai testnet in our hardhat file. And for this, go into your configuration file, and in here I want to add in this networks object, and in here you can specify a bunch of networks. I'll add in the Mumbai network. You can call this whatever you like, and here I need to specify the URL for this Mumbai testnet and the account that I'm going to use to deploy these contracts. And we don't want to hardcode anything here, and actually we want to process the Mumbai RPC and my private key of my account from this secret env file. And this is basically just a package that we'll install. So pull up terminal and just say npm install.env save. This basically allows us in a secret way to store the Mumbai RPC and the private key, because these are private information. And we can require this package here by saying require.env.config. For this you have to configure your env file. So just say new file, and then just say .env, and inside here I will say Mumbai RPC equal to, and then you need to provide your Infura link here. So make sure you get your link from the Polygon Mumbai testnet. This link will basically point to the node we have on Infura. And make sure you put in your private key in here of your MetaMask account. And this MetaMask account needs to have some Matic tokens, because every time you deploy a contract to the network, we are making a transaction that costs money. Not real money, this is just test tokens, so don't worry. And you can get your private key if you were to go into MetaMask. And inside here, once you're logged in, make sure to choose the Polygon testnet Mumbai, and then to see your private key, go inside here into account details, and you want to say export private key. You need to type in your address, your MetaMask password, and then it will export your private key. And make sure you're using this account does not have any funds, any real money inside. And now finally, after all of that's been finished, we can deploy our NFT. Let's just clear the console first. And to deploy, just say npx hardhat, then say run, and we'll run the deploy run token script that's stored inside this scripts folder, and the network is going to be Mumbai. So if we copy this address and go into the browser and search this up into the Polygon blockchain explorer, you can see our run token contract here. Let's do the same thing for our NFT collection and deploy it by saying npx hardhat and run scripts. But this time we're going to run the deploy NFT collection script. And you should get output like this, where you get this NFT contract address. And remember to store this, because we will need those, we'll use this, our frontend will use this to connect to this smart contract on the blockchain. After our contracts are deployed, let's go ahead and go back into our game that we have developed. And inside this blockchain.js file, we'll implement the functions that we have provided in this index.html, like the claim NFT, claim tokens, and the connect MetaMask function. We can now implement these because we have deployed our NFT and token contract on the blockchain. And for this, we are using the ethers object that we get once we have imported the ethers library here using this script stack. the first thing that I need here is an actual provider, and this is like abstraction that connects you to the blockchain, between the wallet and the blockchain. And we'll use the ether subject for this. We'll say ethers.providers.web3 provider, and we'll use the window.ethereum object that gets injected into the browser. Once you have installed your MetaMask, we'll create a signer variable here. This is our signer that will sign the transactions. And let's create a connect MetaMask function. In here, I want to use my provider to send this ETH request accounts function. This will basically allow you to connect your MetaMask to this decentralized app. And once that's done, we can say provider.getSigner to get the signer address. And this is actually a signer object that we're getting, and that also includes the signer address. We'll print out this signer address by calling this getAddress function. And just for a good measure, we'll also get the signer balance and print this out. But when you're printing out the balance, you should convert this to string, because the balance is represented in Wei. Wei is the smallest unit of measurement of ether, and we get this stored inside a big number object. So that's why we need to convert this to string, and we need to divide by this amount to convert the Wei into ether. I'll create a claim tokens function. We'll call this once you get some score into the game and you want to issue some tokens, you want to get your rewards. I'll have this run token contract address. This is where we will put our contract address. Then we have the run token contract ABI. ABI is basically like a JSON file that represents all the function or some of the function that you can call within the contract. And here I'm just providing the mint tokens function because that's all we need. And now we can create a contract instance using this contract address and our token, the contract ABI and the provider. And we can now call the mint tokens function because we have provided this ABI. We can connect the signer, so the signer calls this function and he gets issued these tokens. And this one expects the address of the person that mints the tokens and the actual amount. And we're getting the amount from this window.total Gwei score that we have defined in our other JavaScript files. This is our total score, our total running score. And we're just multiplying this to convert this to Wei. Because this is in Wei, we need to convert this to Wei to pass this to the function. Then create a claim NFT function. Very similarly to this claim tokens function, we'll have a contract address, then a contract ABI, but instead here we want to provide the function signature for our mint function, create an NFT contract instance, and then we'll once again call the mint function on this NFT contract and connect the signer, so he calls this mint function and pass in the amount of NFTs that we want to mint. And also don't forget here to provide the run token contract address and the NFT contract address that you got previously. Once that is done, our game is actually complete. So let's try to test this out. I'll just pull up the console here by right clicking, saying inspect, and going inside the console because we're printing out the balance and the address of the account once we connect this to the console. So let's go ahead and play the game a little bit to gain some score, and then we can claim our NFTs. So I've played the game for some time now, and I've got my NFTs total score to 51 and my Gwei total score, this is not Wei, to 800. So let's connect my MetaMask. And once we have connected to your MetaMask, you can see we get printed out my address here in the console. I'll just zoom in so you can see. This is my this is the address of the account that I have connected, and this is my account balance. So let's now claim our NFTs and see if this works. Actually, first let's claim our tokens. So click on claim tokens, confirm the transaction, And once the transaction is complete, you should be able to see your assets inside here. But if you have not imported your tokens, like I have here, you can click on import tokens, then paste the run token contract address here, and click on add custom token. Import tokens. And as you can see, we have 0.00878, which actually reflects our score that we got. And that's not a lot of tokens because we haven't played the game much. But as you play the game more, you can earn more tokens. Or you can increase the reward. Let's try to do the same things with claiming our NFT. So click on claim NFT. You'll get this prompt from MetaMask. So confirm the transaction. And after the transaction has finished, we can go to testnet's OpenSea and into my profile and make sure you are on the Polygon Mumbai testnet, and we can see that actually, let's go back into the game. You can see we had 51 score here, NFT. So this is how much NFTs we should get. And if I go back to this testnet, you can see that I've got 51 NFTs. And if we request to claim the NFTs for our second time, we'll get a monthly and then a rock, etc. And this means we have successfully created the blockchain game. So if you want to take the next step and learn about blockchain and become a blockchain developer, make sure to check out Dapp University /bootcamp. And until next time, thanks for watching Dapp University.